Hi ladies, this is Mrs. Blaufuss here. This is lesson 1.5 and this lesson is about triangles. So we have a bunch of new vocab words all about triangles, and these three are about a specific triangle. So today we're going to talk about special segments and special angles within triangles and how to classify triangles. So the first thing that we're going to talk about in this lesson, because since we're classifying triangles, we have to know certain things are true about these triangles. So the word assume, be very careful with this. So assume means to accept it without facts or without proof of it actually being true. So we're accepting it as true, but we don't have any proof. So we're just assuming something. Do not assume in geometry. So if you make assumptions, you could get something totally different than what is actually true. So there's this analogy between just words, little words like bug is just a little word, but the difference between lightning and lightning bugs are very different. So the difference between the right word and the almost right word is just the same as the difference between lightning and lightning bug. So be very careful with your terminology and your vocabulary. That's why we'll assess vocab pretty regularly, almost on a weekly basis, but just that is one example of why it is so important to use the correct terms. So on your note sheet, you'll see these statements. So things that we may assume that lines are straight. We may assume that lines intersect at a point. We may assume that all points on a line are collinear. And we may assume that all points on a diagram are coplanar. And this is true unless planes are drawn to show that they are not coplanar. Okay, so if points are not coplanar, it will explicitly say that these points are not coplanar by a given diagram. Now, with these assumptions, they're not really assumptions because these assumptions are supported by definitions. And thus they're not assumptions at all. They are conclusions. So even though we can assume these things, that's not really an assumption. It's based on proof or definitions or given postulates and things like that. We're not really assuming that lines are straight. The definition of a line is that it is a straight collection of points. It goes on forever. I'm going to come back to this one. Things that we cannot assume are that lines are parallel. Here's the symbol for parallel. So we cannot assume lines are parallel unless they're marked as parallel. So given these two lines, to mark them parallel, we'll say L is parallel to M if they have the same number of feathers. So those little arrows we call feathers. And then another set of lines, N and P, we'll say. These are parallel because they have the same number of feathers. Okay, so that's how you'll mark on a diagram that lines are parallel. Or if you see those markings on a diagram, you can conclude that they are parallel. You're not assuming, you're concluding it based on the given information. You're drawing a conclusion. We may not assume that lines are perpendicular. And there's the symbol for perpendicular, unless they are marked perpendicular. So here, L and M, we can only conclude they are perpendicular if they have that 90-degree angle marking. That's how you will mark a diagram perpendicular, two lines on a diagram perpendicular. And then the third thing that we cannot assume is that pairs of angles, segments, or polygons are congruent, and there's the symbol for congruent, unless they are marked with information that tells you that they're congruent. So let's just look at triangle ABC here. Okay, based on the given information, we can conclude that AB is congruent to BC because we have the markings that tell us that. We can also conclude that angle A is congruent to angle C because we have markings that tell us that. We know nothing about segment AC. We know nothing about angle B, so we cannot conclude that AC is congruent to AB, or we cannot conclude that angle B is congruent to angle C because it doesn't have information that tells us that it is congruent. So let's circle the ones that we know. Parallel lines. Which lines do we know are parallel? We know that these two lines are parallel because they have the markings that show us they're parallel. These ones look parallel, but we don't know that they are. We cannot assume that. Okay, what about perpendicular lines? Which lines do we know are perpendicular? We know that these lines are perpendicular because they have the markings. Okay, each angle, and you really only need one angle, but here we have perpendicular markings at all 4 of the angles. This one has no perpendicular markings, so we don't know that those are perpendicular. Which pair of angles do we know are congruent? Here we go, because we have the arcs that tell us they're congruent. No arcs on these angles, so we don't know they're congruent. And segments, a pair of segments we know are congruent are these ones right here because they have the markings that tell us they're congruent. And then lastly, polygons. And remember with polygons, in order to have congruent polygons, you have to have all angles and all sides congruent, corresponding. So here we have a corresponding side, and I could go through and draw all of the sides and all of the angles corresponding on these polygons. So these polygons are congruent because they are marked congruent. These ones, they look congruent, but we don't know that. We don't know that they're congruent. We cannot assume they're congruent just because they look congruent. So take a minute. I'm going to pause this video, or you will pause this video rather. Pause while you work, and you can unpause for the solution. Okay, so here are our solutions. The pairs of lines that are parallel are IK, or any of those 2 letters, IJ, IK, JK, KI, in any order because it's a line. So IK and DE, or DF, DG, DH, HE, any order of the any 2 points on that line. Lines that are perpendicular, we have this perpendicular marking right here. So line FB or JB or FJ, any of those 2 points on that line is perpendicular to AC. Again, you can use any 2 points on that line AC. So it could be AB, BA, CA. And then lastly, which pairs of triangles are congruent? Remember, to have congruent triangles, we need all corresponding angles and all corresponding sides are congruent. So I'm just going to look at the corresponding angles first. D and H are corresponding, B and G are corresponding, and I and K are corresponding. And if I look at my markings, I can see that they each have the same number of arc and tick marks on them. And then if I look at corresponding segments, I can see that DE and HG both have 1 tick mark. I can see that EI and GK both have 3 tick marks, and I can see that DI or ID and HK or KH both have 2 tick marks. Okay, so that's true. All corresponding angles and all corresponding sides are congruent, therefore my triangles are congruent. So here we're going to look at some definitions. On your note sheet, you have several terms. You have right triangle, scalene triangle, isosceles triangle, equilateral triangle. So you have all of the terms that were at the front of the lesson. And what I want you to do is, based on these diagrams, right triangles or not right triangles, I want you to create a definition. So what is always true about right triangles that makes them right triangles? What do they need to have? And on your note sheet, please also draw a diagram. So here, and we'll go back and I'll give all of the definitions after you view all of the diagrams. Okay, let's look at acute triangles. Just pause the video as if you need more time. Acute triangles, what is always true about acute triangles? The next term is obtuse triangles. So what do you notice about every obtuse triangle? Then we have scalene triangles. Next is equilateral triangles. We've had this term before, equilateral. And then the last one, isosceles triangle. So take a minute, pause the video while you work, unpause for the solution, but draw a diagram and define the term. A right triangle is a triangle that has exactly 1 right angle. So a right angle, remember, is 90 degrees, and it's marked with a right angle mark or it's labeled 90 degrees. This, although it has a right angle, is not a triangle. An acute triangle is a triangle that has all 3 angles are less than 90 degrees. Remember, acute means less than 90 degrees. And all 3 of them have to be acute. Here we have 2 acute angles, but this is not acute. Therefore, that is not an acute triangle. Okay, the next term is obtuse triangle. In this case, we need only 1 obtuse angle, and that's an angle that's greater than 90 degrees. So although this has an obtuse angle, it's not a triangle. Here, this is only 90 degrees, so it's not obtuse, so it's not an obtuse triangle. But in the other 2 that are, this is greater than 90 degrees, and here we go, 118 is greater than 90 degrees. A scalene triangle is a triangle where no 2 sides are congruent. So all 3 sides in this example are of different length. Here we can see that these are all 3 the same length. That would be an equilateral triangle. Here we can see that we've got a 90-degree angle. That makes it a right triangle. And we can also see that 2 of the sides are congruent. And this one, lastly, is not a triangle, therefore not a scalene triangle. An equilateral triangle is a triangle that has all 3 sides congruent. Okay, so here we can see all 3 sides and all 3 angles are congruent, which will in fact always be true for an equilateral triangle, but the definition just has that all 3 sides are congruent. Okay, so this has 3 congruent sides, but Again, not a triangle. This one has no markings, so we can't determine that it's an equilateral triangle. And then the last one is an isosceles triangle. In an isosceles triangle, we have at least two congruent sides. So here we have two sides congruent, and it's a right triangle. So this is an isosceles right triangle. Here we have three congruent sides. That makes it an equilateral triangle, which is a special isosceles triangle. And here we have the simplest form, just two congruent sides. Two congruent sides. Those are both isosceles triangles. So this last diagram is specific to an isosceles triangle. Okay, so all of these terms are for isosceles triangles. We know it's an isosceles triangle because it has two congruent sides. The two congruent sides form this vertex angle. Okay, and a vertex angle is an angle formed by the two congruent sides. These two angles that are not the vertex angles are called the base angles. And the base angles are the two angles that are opposite of the congruent sides. This word opposite, when we say opposite, it's the side that doesn't touch or the angle that doesn't touch the side. So I'm going to give you an example here of how to find the opposite. So if I'm looking at this side, the side with those two purple points as the endpoints, if I'm looking for the opposite angle, it's the angle that doesn't touch that side. Okay, so in a triangle, the angle that does not touch the side is the opposite angle. Okay, and then the last term is the base. And the base is the side opposite of the vertex angle. So again, if I'm having trouble deciding where the opposite side is, I'm going to put a mark, or you can use your fingers, on the vertex angle and see how that vertex angle touches two sides of the triangle. It touches this side and it touches this side. The base, or the opposite side, is the side this angle does not touch. So that's all for this lesson. There's a lot of new terminology. We will learn about properties of all of these special triangles in later lessons, but today we just are defining them and learning how to, or just practicing more, how to mark our diagrams and understanding the importance of not making assumptions, using actual evidence. So please jot down any questions you have and bring them to class, and we will discuss them next time I see you. Thanks, girls.